All right, second half of chapter 2. We're going to talk about quantitative data, and we have two different recordings on quantitative data. This first one has to do with small data sets. So small data sets have a limited number of numbers in them and probably have a whole lot of repeats. A dot plot. A dot plot is what I call one of your quick and dirty little graphs. It's probably not something you would do for a formal report. When you look at a dot plot, you can get the original data values back, and it's not something you want to do if you have too many data values or if your span of numbers is too great. If I look at my list of data values, I need to find my minimum and my maximum. Otherwise, I don't know where to start. That's something that's very, very common when you have quantitative data. Minimum and maximum kind of set you up for where you need to be. So if I look at my data, I think the smallest data value I see is 15. So my minimum is 15, and my max, my highest number, is what? 30. So, minimum is 15, maximum is 30. What I want to do is I want to make a number line that goes from 15 to 30. And I need a tick mark for every single number, 15 and 30, everything in between. This is why I wouldn't want to have a large span of numbers. Get any bigger than this, going from 15 to 30, it's a number line I don't want to draw. Now, I've started the dot plot for you. If I start 23 would make this dot here. Then 25 would go here. Notice when I make these dots, they're not on the number line, they're above it. And all of the first instances, 23, 25, 30, they're kind of level with each other going across. Then when I hit a repeat like 23, I leave a space, and everything that has a second instance will be like along that line, and all the firsts will be kind of along there. So you're not really like being so anal that you got to use graph paper, but you want to be neat about it. Otherwise, you might as well not make the graph because it's not going to tell you anything. So you should pause this recording now and see if you could place the rest of those dots above where they belong on the dot plot. And this is what your finished product should look like. You can see where you have stragglers who are out here by themselves. You can see where you have the most common result. So you can tell that this stuff is kind of clumped up. You got another clump here, and then you got a lonely guy out there. So a dot plot is just a quick and dirty of how does my data lie. I know a little bit more information now than I did before. A stem and leaf plot is another quick and dirty. It's another way that I can keep all the data values retrievable. Must include a key, and we'll talk about what that is in a minute. Again, I have a pretty small data span here. To verify that, let's find the minimum and the maximum. If I don't do that, I don't have any idea what it is that I'm doing. So my smallest data value my highest data value is 37. So I go from single digit numbers up to 37. With a stem and leaf plot, you choose your stems, and a lot of times, since I have 2-digit numbers, my stems are just going to be whatever digit would be in tens place. So if I start at 5 single digit numbers and I go up to 37, then my stems are going to go from 0 to 3. These will be your single digit numbers, your teens, your 20s, and your 30s. Then the ones digits are your leaves. So if I start at the beginning, my first data value is 18. Oh, I'm sorry, it's 13. On my screen I have something covering it. My first data value is 13. So that has a stem of 1 and a leaf of 3. My second data value is 9. 9 has a stem of 0 because it's a single digit number and a leaf of 9. Now 18 has a stem of 1 and a leaf of 8. So I just want to put the 8 digit over there in the leaves, but kind of like the dot plot, I want to leave a little space, and everything that has a second instance will kind of be in that column. So instead of building this up, we're building this sideways. So you can continue that pattern and pause this and see if you can finish out this stem and leaf plot. That's what your finished product should look like, at least for the stem and leaf plot. But just looking at the stem and leaf plot does not tell me how to read it. You've got to have a key. When you make the key, you pick any number that appears in the stem and leaf plot. I just happened to choose 13, and this key says if I have a stem of 1 and a leaf of 3, and that's the dividing line between the stem and the leaf, 1 on the stem side, 3 on the leaf side equals 13. Now this is also called an unordered stem and leaf plot because if you look at the digits that are in the leaf column, they're not in any sort of order. They're just in whatever order the data came in. So again, this is really kind of really dirty on the quick and dirty. You could tell a lot more information if you just rearrange your leaves. If you put them in numerical order and you see them going from smallest to largest, repeats show up more clearly, and not only that, you could see what numbers are missing.